Alrighty, good afternoon, everybody.
Hello.
Everyone's full from lunch, ready to take a nap. Hopefully, I don't bore you to death. Oops. Just out of curiosity, how many Capital One folks are in the room?
Woo.
Okay, good, awesome. My name is Adam Auerbach. I run the Advanced Testing and Release Service group here at Capital One. I am the well, I used to say I was the last testing leader in the organization, but we've hired a couple people, so I can't say that anymore. So we're going to talk about continuous testing. So Capital One, as many of you do know, right, we're one of the largest digital banks. We are more than a credit card company. We also have financial services, retail bank, commercial bank, as well as a digital group. But we're only 20 years old, so we're relatively young in this industry. So Rich Fairbank, our CEO, he made this statement, and the big thing that we're pushing here is that our competitors are not the other big banks. Our competitors are technology companies. Our competitors are the Apples, the Googles, the PayPals. And so in order to be able to compete with them, we ourselves need to be a technology company. And so what does that mean? So first off, we need to build our software ourselves. Many years ago, we would have lots of third-party vendors building our stuff. We'd buy COTS products, and that's kind of how we put together our systems. So that has changed, right? We're building it ourselves. We're hiring engineers. We're building on the cloud. Our CIO, Rob Alexander, said we're going to be the first bank in the cloud, and lo and behold, we are. And we have a pretty aggressive plan to reduce our data centers over the next several years because of that. Microservices, so we want to use a microservice architecture, get rid of those big monolithic applications, reduce those dependencies. And of course, we want to be using open source. In order for us to build our own software, we need top engineers. And in order to have top engineers, they have an expectation that they're going to be able to use and contribute to open source. And so we ourselves, as a financial company, we need to embrace open source as well. And then lastly, we need to be practicing DevOps and continuous delivery. In today's digital world, people have an expectation that they're going to get updates in real time, that their apps are going to be updated, on a regular basis. It's not going to be months. It's going to be, days. As soon as there's new technology out, they expect their app's going to be taking advantage of it. So our big mantra here is around delivering high-quality working software faster. So what does that mean? So high quality, so obviously we don't want any security flaws, no legal flaws, minimum defects, and testing is happening all the time. Working, obviously it's got to work, and faster right now, right? So pipelines are critical, and there's many different types of pipelines. So there's pipelines that go nowhere. There's pipelines that look like this. And then more often there's pipelines that break, and we're left to fix them. So this is where we start to figure out, hey, how do we get to a place where it's repeatable, where we have constant flow and quality, and we don't have situations like this or like this where it's tough to debug and figure out where there are problems. So a pipeline basically is every time there's a commit, we're doing a pull request, a build's happening, we're running tests, and we're able to deploy. And as part of that, everything goes through that pipeline. That pipeline is our automated assembly line, if you will. And so our code changes, the infrastructure changes, our tests, everything is part of that pipeline. And that pipeline handles all of our different environments. You do a pull request as a developer when you first made it a change. It does a compile, it runs your unit tests, it runs your automated tests. It then merges that code. Then another series of tests, perhaps a canary build is done to stand up an emulator to run those tests, and then so on and so forth until we're able to release. And that's for everything. And by having an automated pipeline in place, you're able to have constant flow to production, right? you're able to focus on building features for your end users and not having to spend time on someone dedicated to making the builds and packaging and deploying, and another person who's running my tests and other people. If the team can focus on building features, then that we're going to be more productive. We're going to be able to do more. We're going to be able to deliver more. And so having flow and making flow your key focus is critical, as well as fast feedback. We know that a developer who code something today, is going to be able to fix something easier today or within an hour than if they have, in a week or two, have to go back and try to fix something, or even later. So we want to tell people that something doesn't work as soon as possible. And we want them to be able to know that themselves without having to rely on all these other people. Part of embracing a DevOps culture is that we are all accountable for quality. How many people here are testers or consider themselves a tester? Okay, so that's most of you, right? So I don't have to talk to you about quality. I should probably be giving the same talk to the room of developers that are over there, right? But that's DevOps teaches us that we own quality. We own the features as a team. We own quality. It's not just each of you who are responsible for quality. It's everybody. And so how do we break that line, break that wall down, and so that we're getting feedback throughout? And then obviously, we're making sure that we're well managed. And so how do we make sure that our separation of duty controls, our test coverage, performance, security, all of those things are also included in this pipeline because we're a bank and we have regulators that we need to make sure we keep happy. So all of this is possible through continuous testing. Now there are other things, obviously, from an architecture perspective to do this, but continuous testing is a key enabler to getting to continuous delivery. And so let's talk about how to get there. Now, I only have 24 minutes left. So I'm probably not going to have time for a lot of questions, but the remaining talks after me are going to talk about ATD. They're going to talk about continuous integration. We heard one earlier about service virtualization. So hopefully I get your appetite hungry for the future talks that are later. All right, so what is continuous testing? So basically, continuous testing is all of these things happening as part of our pipeline all the time. So when I check in code, I have a pipeline that when I do that pull request, my build runs and my unit testing and security testing are happening automatically as part of my pipeline. And then once that works, my next series of testing jobs are running. And that's not just acceptance testing, from the UI perspective, but also from the API, but also performance and security. Everything that we need to do in order to say this is really done, it has to be automated and it has to be part of my pipeline. Now it also might mean that you have to change the way that you think about doing some of this stuff so that it can run quickly and can be automated. But this is the goal.
Question?
Yes. Sorry.
About building your own code. This is a Capital One.
Yep.
And I understand that. I'm saying in a lot of environments you have partners, and this partner brings this part of the service, and this other one.
I'm going to hit that in a little bit, but yep. So the question was around interoperability. So just give me a little bit, and
Okay, thank you.
Hopefully I'll answer that. All right. So that's actually a good question. So. Obviously, all of you are dealing with devices and browsers, and there's many different devices, many different operating systems, different configurations, all of that you need to be able to handle, right? So we need to be able to solve that in an automated fashion. Environments, same thing. I need to be able to have test environments. I have downstream dependencies. They have to have high availability environments for me to be able to test in. I need data. At Capital One, many of you are very familiar with what it takes to get data. I need a bank account. I need an account that has a home loan. I need a credit card with certain transactions posted, certain balances. Data is a big constraint when you talk about I need to have tests that are atomic, that they're able to run repeatedly many times a day, and they, I can't be failing because I don't have the right data. And I can't spend a lot of time conditioning every single test because I'm not going to be able to run them that fast. Dependencies, like you mentioned, many of you who are doing Android development at Capital One know that most of the APIs or other things that you need aren't in your control. And so how do I test my application to its fullest when people aren't ready with their pieces? So how do you eliminate that? And then what and when? And then how do you do this? What tests to run, when to run them? And then dashboarding, giving people the ability to understand when things are failing, when they're not working. So these are the challenges, on running all those types of tests early and often. So how do we solve these challenges? Oh, and of course, people, all of you. So one of the big things at Capital One is that we've realized is that there's been a transformation in testing and engineering in total, but in testing specifically, all of you have skills today that you may or may not have had a year or even 6 months ago. So I'm going to talk about that too. All right, so let's talk about the first solution, real-time test automation. So a couple years ago, we started rolling out acceptance test-driven development. And what that basically says is, as part of our stories, we're going to partner with our product owner and our developer, and we're going to write our stories in such a way that we have acceptance criteria specified in Gherkin, and that's what we're going to code and test to. And by doing that, we get alignment with our team early and can ensure that how someone's going to use our applications is being baked in right from the onset. Test-driven development, so we're asking our developers to write unit tests for all of the things that they're developing. We're using tools like Sonar to be able to run those tests and be able to track coverage. And while we haven't done this well as an enterprise, many teams have code coverage metrics that they track to and hold a high bar to. And then I talked about acceptance test-driven development, so using tools like Cucumber and Ruby, Cucumber and Java, Appium, Calabash, being able to take those scenarios and create automated tests that are tied to them so that we have full traceability. So this is critical as far as being able to keep pace with developers and having automation ready so that when someone's checking in code, I have automated tests, unit tests and acceptance tests that go along with that code, as well as that developer can run that stuff locally to make sure things are working before doing their pull request. Open source tools, so I mentioned a couple of them. I know I probably don't have to tell this group, but we shouldn't be buying tools anymore. There's so many wonderful tools out in the open source market today. We need to be taking advantage of them. By using these types of tools, we're able to do things quickly. Now, they do require programming. They do require a higher technical aptitude than if you had some type of abstraction layer on top of that. But what we find is that by using these tools, you can you can automate quicker, it will run faster, and when you have a framework or an abstraction layer like we used to have, what happens is you spend most of the time maintaining that abstraction layer. We used to have a keyword-driven framework that used UFT or QTP, and we just spent a ton of time maintaining it, and that's not fast enough. And so open source gives us a ton of capabilities that you have to be ready to be able to use. Test data. So at Capital One, this is a shameless plug since my team built this. So we built a tool called OneSource, and OneSource basically exposed all the different APIs to feature teams so that they're able to get their data themselves. So how do you empower your feature teams to get all the integrated data that they need in real time without having to know all the different systems where their data resides? The other thing that we've just done with this tool is we expose the API so that as part of your pipeline, you can call an API to go create an account or condition account, and then when you run your automated tests, all you have to do is run your validation. You don't have to, or your assertions. You don't have to go and do all the conditioning. So we just actually had a KT session with Vanguard. And test data is a big issue with them. They don't, every team is kind of fending for yourself. And when you look at all the tests that you run, where people spend most of their time, it's conditioning data. Why didn't I see this defect? It's because I didn't have the right data. Why is something, data is key. And so spending time to build tools that empower your teams to be able to have this at their fingertips so they can focus again on features is critical. Service virtualization. So I love the presentation that kicked us off this morning around the service virtualization. We started looking into virtualization because our performance test environments aren't scaled. And so when you talk about performance testing an application and you have limitations on your back-end systems, you can't do a lot of performance testing. So we started looking at service virtualization as a way to help scale out our performance testing environments so that we could get more realistic results. But what we found with service virtualization is many times you're testing, let's say I'm testing, I have a browser that I want to see how it renders on my Android device. I don't need to run a full end-to-end test to do that, right? I can use service virtualization to stub out my back-end systems. I can data drive it with a JSON file so I can have all the same expected results as I would if they were doing an end-to-end test. And I can just run it. I can run my tests on the different browsers just to, or different devices just to make sure it's working. So service virtualization is a great way to eliminate constraints and speed up what is the purpose of this test and because I don't need to do an end-to-end test every single time. They're long. They usually break. So why run them a lot? You don't want to. You want to run them a little bit. And so you want to try to do component level tests, and service virtualization allows you to eliminate that constraint. Also, many times we have dependencies on another team to build our APIs. What I can do is I can take the design file from the API team, I can create a virtual asset, I can program it in such a way that I get all the expected responses, I can write all the automated tests for my application, I can run them, I can make sure with confidence that my app is working, and then when that API is available, like those test suite will still run, and then it'll be on that team to have to fix something if it's not working at that point. But at least I have confidence that what has been developed has been really tested. So service virtual, I can't talk about service virtualization. I probably could do a whole speech on service virtualization because I think it really is a key enabler to getting to continuous testing. Environments, I know we have Perfecto Mobile here, and you're going to hear from them later today. Perfecto Mobile, Sauce Labs, TestDroid, these solutions are really powerful. Being able to take Perfecto Mobile, being able to hook it into your pipeline, being able to run your tests against multiple devices in real time is needed in order to be able to do continuous testing. Obviously, we have tier 1 devices and operating systems that we need to certify on, so having them available in an automated fashion is critical. Capital One, we're looking at some open source tools. We actually built an open source device management system. We're working with a couple of the teams right now to test that out. But again, you need to eliminate your constraints. You need to be able to have different browsers, different devices available to you. And so using one of these solutions is also very important. All right, another shameless plug, so Hygieia. Hygieia, when we started the open source journey, what better way to figure out open source but to eat our own dog food and try to contribute back to it? And so Hygieia was Capital One's first foray into open source. And so we built this dashboard. It got Rookie of the Year last year from for open source tooling. And this dashboard is about giving teams fast feedback into where they are with their builds, with the commits, with the code quality. But one really cool feature that we just added in is this product view. And what this does is it gives you, each one of these rows is a separate pipeline. So you might have a UI, an API, the application layer, et cetera. And so for all the different pipelines that you have that make up your platform, you can see, hey, someone checked in code in the commit, how long does that code take before it gets into a build, before it gets deployed to testing, how long does it sit in testing, in integration, performance, and how long eventually does it take to get prod? This is one of the key metrics. If you go read the Puppet Labs DevOps 2016 survey and you talk about flow, this is your time to market. And this is what we're trying to improve. And so this dashboard gives teams insights into where they have bottlenecks. And what we found with the first teams that started using this is that performance was probably one of our biggest bottlenecks. And so it gave us insight on how to use like open source tools like JMeter and bring performance in early. Also, we use tools like New Relic and App Dynamics to be able to put some monitoring in place in non-prod so that you can get insights early from a performance perspective and reduce the need to have to do a long-running performance test at the end. But this is the end goal, and it gives you visibility into where the bottlenecks are within your pipeline. And it's a great way to figure out, like, hey, we're not there today, where do I start? Just looking at how long a commit takes once a developer checks something in, how long does it take to actually get into production, and then going from there is a great way to figure out where to start. Another thing, I don't have a slide for this, but this is very evident in people's branching strategies. So at Capital One, we've been looking at branching and looking at best practices. And one of the things that we've seen, which shows up here from a time perspective, but when you see people's branching strategies, one of our mobile apps, they have a feature branch, then they have a release branch, and a hardening branch, and then their production, their master. And when you start talking through, like, why are you doing it like this, you can start to hear, where they don't have good unit testing, where they don't have things automated earlier in the process. And so, like, if that team, and if you just think about it, think about the time people are wasting. We did a value stream analysis on a team who had 10 people, and one person was fully dedicated on builds, another person on deploying, another person on automation, and automation was after the fact, and then they had like a 30-40% defect leakage rate. So when you actually get into all the numbers, like, they were losing 40 to 50% of their capacity because of doing all these different activities. So that's the, how do I sell this to my business? Like, your teams are going to be more productive. We're going to be able to do more by investing in these technologies. So I mentioned about people. We have seen a change in our testing community at Capital One. As we've been on this journey, it requires testers to know these open source tools, which does require knowing a programming language. In order to do continuous testing, if I'm a functional tester and I need to be able to use Cucumber and Ruby or Cucumber and Java, for example, I need to also understand how does that plug into Jenkins? If I'm using AWS or some cloud provider, how do I best optimize my tests for that technology? And so what we're seeing is that all of these different specialized testing roles are evolving because they have to know all of these different technologies. And now you're seeing that testers are getting very close to the same skill set that a developer has. And you'll even see teams where they don't call them developers and testers, they just have a team of engineers. And that's the future, that's where we're going. We have some lines of business today that's what they have. And there's debate on whether or not we even just drop the testing job family altogether. Because we all should be engineers. We all should have some level of programming in what we're doing. And we all need to own quality, and we need to understand these technologies. So as far as scaling goes, we do things at an enterprise level to put things available for people, because this isn't easy. We do lots of trainings. We we create a inner source community within Capital One so that whatever frameworks are available, people can take advantage of them and enhance them. And that's really important because as a community, we're all kind of dealing with some of the same problems. And if we share information, we can get get there faster. Also, we do lots of events like this. We do A2D open spaces, which are a great way of bringing people together and just talking without having like a formal agenda. We have office hours. We participate in meetups. This is another great way of just getting people together and talking and sharing best practices and learnings, or even sharing problems and getting them together to help solve a common problem. What does this mean for me? Like I said, testers have to learn a programming language. You have to understand the CI tools. I say be able to apply the enablers. So those are the things that I'm talking about. You should know service virtualization, whether you're using the tools that we've bought at Capital One or using the open source tools. You need to be able to take advantage of those things. If you don't have a test data management team who's building cool tools, well, like how can you do things in order to enable your teams to have the data that they need? You need to have you need to be able to do those types of things. Development. We need to be working with developers. They need to have accountability for quality, which means they need to write code that can be automated. Many times I've tested things where like the properties are all messed up. It's just not well written. The automation, you just have to it keeps failing because of the way the code works, and developers have to have accountability to fixing that, because at the end of the day, it's about checking in working code with working tests. And that's not just the tester's responsibility, it's the team's responsibility. So that's something that we need to all work on. Working in pairs, doing pair programming is a great way when you're starting this journey and you maybe don't have all the technical skills yet. Pair programming is a great way to maybe leverage the developer's technical skills, but your ability to break the app. It's a great way to learn. And all right, I think I have 4 minutes, right? 4 minutes? All right, questions? No? Oh, yes, right. Yeah, I only can do probably a couple questions because the next person's got to get set up.
So part of your Hygeia,
yes, Hygeia.
Or one of the new features that you're putting into place would be tracking, that one right there.
Yes.
I know currently we have, like, for example, Atlassian, Confluence, and Jira, and you can track each status, it accumulates time, for example, in testing in dev.
Mm-hmm.
Is that your approach of how you're tracking the time, or is there a different way?
Yeah, so each one of these boxes is actually like a commit. So in Confluence or Jira, like you're able to see that at a story level or a ticket number. Like this is the aggregate of all of that.
Okay, cool. Yeah, this is really cool. Thank you.
Awesome. Yes, sir.
My line of work is related but different. It's on Android, but it's military applications.
Okay.
I'm the chief tester for NetWarrior and mounted mobile handheld computing environment in the Army. And essentially, smartphones come to riflemen.
Wow.
Which is a real innovation. And of course, our constraints are different than yours. But this whole notion of combining development and test is key to the way we're approaching it.
Yes.
You were talking about doing away with the distinction between developer and tester.
Yes.
We, instead of use continuous, we use words like contemporaneous.
That's too big to spell.
The attempt is to make it organic, and it ties back to one of the original contributions to this, which goes all the way back to the middle 70s, which was software code inspection, where essentially the developer, the author of the code, participated with his peers, who were also coders, in testing, at least in a paper sense,
Yes.
of what they were doing.
Yeah, some of these things are definitely like a throwback,
I mean, it's like, that, from my perspective, that's one reason why I'm willing to go with it, because it is genuinely not rocket science anymore. It is proven. We're just combining it and using it in different ways.
Yeah.
Okay? But did want to get back to the question about when you have partners, where you have to cross, where your services cross organizational and functional
Yes.
physical boundaries. How do you work that? We call it interoperability.
Yeah, so that's a great, so the interoperability. So if I had longer, this talk starts with focus on Agile. So our Agile transformation at Capital One was the first driver into this. And when we first started that transformation, we had component teams. So you had teams that were, someone did the UI, someone did the API, someone did the back end, very similar with third parties. And so what we've seen of lately is trying to build feature teams, putting all of those different pieces together on one team so that they're able to deliver a feature versus just components. And then when you have third parties, again, I go back to service virtualization, being able to eliminate that constraint so that from our perspective, we can make sure that we are really done instead of like, I did my part, now I have to wait, and then when I get their thing, I'm going to test, and it's probably not going to work. And so service virtualization is not just stubbing, but it's making those virtual assets as robust as possible so that you are able to,
To have operationally and technically realistic interactions.
Yes. The other thing I will tell you too is from an A2D perspective, one of the things that we've done with like some of our third-party vendors is if they're doing development for us, give them the Gherkin statements. So instead of giving them traditional requirements, you give them the acceptance criteria and ask them as part of their deliverables, they're giving you back running automated tests. So there's some of those types of things that you can do with third parties to put them on the hook that they're not just throwing code over to you as well.
Okay. So that's another piece of what we're trying to do, which is that we say building it to standard, which
Mhm.
is correct by construction, but there is.
But how do you enforce that? And
That we have 5 stages of it, and the first stage is inspect and specify, then design and assemble, then implement and build, and then conformance and compliance,
Mhm.
and then you certify all 4 of those. But at each point, you take something that is more abstract and subjective on the left-hand side, and you formally specify it on the right-hand side. So you take your requirements, that's a document in human text, and you turn it into a specification that is a
Yep.
regular expression grammar.
yes, exactly.
And you do that at each stage. You take your design, which is scribbles on a whiteboard, and you turn it into a specification, which is a regular expression.
Yep.
And okay, so is that consistent? And our whole deal is you're not done until you have the rigorous specification of what it is you build. Okay? You have a reference design that says this is how we designed it. Then you have the actual build and the demonstration that it functions the way it's supposed to. Then there's a compliance, it does meet all the standards. That group of 4 things then constitutes the package which is ready for delivery.
Yes, and so when we talk about A2D and B2D, same thing, specification by example, using Gherkin language as yes.
That was my next
Awesome.
Okay, thank you.
All right, I think I'm out of time. Oh, one more question? Last question.
Next is yours.
Oh.
Just getting to.
Oh, okay. I think that's it. All right, thank you, everybody.
Yeah, I know Adam, we didn't have much time on the QA. In case if anybody want to catch up with Adam, he has a Twitter there, and you guys can reach to him. I apologize for not time for the questions.
It's all Bashkar's fault.
Yeah, I think I'm the leader of this.